Hello friends, now audio is clear. I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Once again, a very good afternoon to all of you. Welcome to the session. Hi, Mr. Raghu, how are you? Welcome to the session. So friends, today in this AIMER'S series, which is a free crash course for your GATE 2023 examination, today I'm going to start one of your most favorite subject, that is power system. I will be talking about transmission and distribution system. We'll be doing some questions, and with the help of the questions, we will try to understand the important concepts, even though the questions will not be repeated in the GATE examination, but definitely the concepts are going to be repeated in one way or the other way. Okay, so all the candidates who are joining me live, just quickly hit the like button, like, share and subscribe. Just share this session with your friends and colleagues so that everybody gets the benefit, and subscribe to BYJU'S Exam Prep so that you do not miss any of the important session for your preparation. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience. I'm tech from ITBHU in 2010, written a couple of books, and these are my areas of expertise. Before we start the session, let me tell you that if you are not aware, BYJU'S Exam Prep is currently having a GATE previous year question series for the last 5 years, and let me tell you, this series is going to be extremely important for you. We are covering 2018, 19, 20, 21 and 22. All these 5 years questions, and number of subjects already completed and some subjects are running, and tomorrow I will be having the previous year questions for power system. The timing is 9 p.m. in the evening tomorrow, that is 29th of December 2022. So already it was started 18th of December, or so many subjects we have completed. Tomorrow 9 p.m. same channel will be having the power system previous year questions. Mr. K, wait. Another important series we are going to start from 3rd of January, that is Maha Marathon series. Within just 12 days, all your technical subjects we are going to cover. You are getting a full revision for all your subjects within just 12 days for electrical, electronics, instrumentation and computer science students. So do not forget to subscribe to the channel so that you do not miss these sessions. Another important information regarding the GATE and Engineering Services Test Series. You will be getting full-length mocks, subject-wise test. The link is given in the description. You can follow it. The important quality of this test series is that you will be getting 60 plus tests covering GATE and Engineering Services, detailed mock analysis, virtual scientific calculator. It is curated by the GATE experts. You will be getting all India mocks also, and you will be having 4,000 plus practice questions. So let us start with the first question. Okay. Yes, definitely in the revision series you will be getting the concepts also. Okay, so all the candidates who are live with me, just let us try to do this problem. A 15 horsepower 440 volt three-phase motor is operating at full load, 85% efficiency and 0.9 power factor lagging. He is asking what is the real and reactive power drawn by the motor. Now you understand, suppose this is a motor. Let me use another page. Suppose this is a motor. This is the shaft of the motor. Now motor is going to get some electrical input from the supply, and this electrical input supply is going to give rise to an electromagnetic torque. If the rotor is free to rotate, the rotor will rotate in the same direction. But if there is some mechanical load connected, then there will be an opposite torque, that is load torque. This is how we are defining the motor operation. The output of the motor is mechanical power. The output of the motor is mechanical power. If you see the question, in the question he is saying the power rating is given in horsepower. It means he is giving you the output of the motor. So if you know the efficiency, you can write output upon input. The efficiency given is 85%. So this is 0.85. From here you can find what is the real input power, because efficiency you relate with the real power, not with the reactive power. Output is given as 15 horsepower. So 1 horsepower is approximately 746 kilowatts divided by 0.85. To solve this, you will be getting the real power input taken by the motor from the supply. Now, in order to find the reactive power taken by the motor, this is P input, this is Q input, and this is P input square plus Q input square, and this is the phi input. You know what is the real power, you know what is the power factor, so you can find the power factor angle, and from this triangle you can write the input reactive power as P input tan phi input. P input you have just calculated, this is 10, and phi input becomes cos inverse 0.9 because power factor is given as 0.9. So it is cos inverse 0.9. Everybody just tell me, can you solve this? So as far as I can remember, you must be getting B as the correct option. This is the real power and this is the reactive power. See the next question. A single phase load is supplied by a single phase voltage source if the current flowing from the load to source is 10 angle minus 160 and if the voltage at the load terminal is 100 angle 60. He is asking what is the nature of load, whether the load absorbs or supply the real or reactive power. So in this question, basically you have to apply the sign convention for the load. The situation is something like this. A single phase load is supplied by a single phase source. He is saying the voltage of this bus is 100 angle 60 degree. It is 100 angle 60 degree. And the current is mentioned from load to the source, and that is given as 10 angle minus 160. It is 10 angle minus 160 degree. Now suppose you want to write the complex power for the load. How you are going to write it? You will be writing the complex power for the load as voltage current complex conjugate. But whenever you write the complex power for the load, the current is always coming from source to the load. This is the current which is taken by the load, because the basic nature of load is to absorb the power, to take the current. But the current given is going from load to source. So how to write it? What you can do is, you can draw the phasor diagram. Suppose this is the reference phasor. This is the voltage. It is 100 angle 60 degree. The current load to source is given as 10 angle minus 160, somewhere here. It is 10 angle minus 160 degree. But we want the current going from source to the load. We want this current. So this current is going to be the current I, which is minus of 10 angle minus 160 degree. So just take the opposite of this phasor. So it is going to be something like this. This is current I, which is minus of 10 angle minus 160 degree. What is this angle? Can you tell me? What is this angle? This angle is 60 degree. What is this angle? This total angle is 160 degree. So this is going to be 20 degree because the total angle is 180 degree. So can I write this current phasor I as, because magnitude will not change, only the angle is going to change. So it is 10 angle 20 degree. Can I write it? Yes. Now just put the values. So it is going to be 100 angle 60 degree. For the current you can write as It is going to be 10 angle 20 degree, but you have to take the complex conjugate. So it becomes 1000 angle 60 minus 20 is 40 degree. If you solve the real and imaginary part of this, you will be getting the real and reactive power, and both will be coming as positive. Positive means both the real and reactive powers are being absorbed by the load. So A is the correct option. Is it clear, everybody? Are you able to follow this? Is it clear, everybody? See the next question. Let a 10 kVA 400/200 volts transformer be approximately represented by a 4 ohm reactance referred to the low voltage side, that is the 200 volts. Considering the rated values as base quantities, what is the transformer impedance as a per unit quantity? Now you know. Let me discuss this case because it is important. It is a 2-winding transformer. Primary side voltage and current is V1, I1. Secondary side voltage and current is V2 and I2. The number of turns are N1 and N2. Okay. And suppose the impedance of the primary side and secondary side is Z1 and Z2. So if I want to write the total effective impedance referred to the primary side, how it is going to be? It is going to be referring the secondary circuit to the primary side. So it becomes Z1 plus. Because you are referring Z2, Z1 will be as it is. So simply I am writing Z1. You are referring Z2 from secondary to the primary. So Z2 has to be normalized. From where you are coming, divide by the number of turns, to where you are going, number of turns, and do the square. Similarly, if you want to find the total equivalent impedance referred to the secondary side, so the secondary side impedance you can write as it is, plus primary side impedance multiplied by N2 upon N1 to the square. Now, if you want to find what is the per unit impedance, suppose you want to find the per unit impedance. Now, the per unit impedance, whether you find it from the primary side, it is going to be Z01 upon Z1 base. Or if you find it from the secondary side, it is going to be Z02 divided by Z2 base. You know that in per unit, the primary or the secondary per unit impedance of the transformer is same. In the question, he is giving you the low voltage side. So basically, he is giving you this value. Basically, he is giving you this value, that is Z02, because secondary side is low voltage side. So Z02 approximately represented as 4 ohms. You need to find the secondary side, low voltage side base impedance. Then you can easily find the per unit impedance. The secondary side base impedance is going to be voltage square, that is 200 into 200. That is complex power square, that is not square, simply complex power, 10 into 10 to the power 3. So if you simplify this, you will be getting this also as 4 ohms. Then what is going to be the per unit impedance? It is going to be 4 upon 4, that is 1 per unit. So what is the correct answer? A. Is it clear, everybody? Just tell me yes or no. Are you able to follow this? Just give me one moment, okay? Don't go anywhere. So sorry for the disturbance. Any doubts? Let us move. Now this question talks about the bundled conductors. A hypothetical 2 subconductor system is to be designed as a 4 subconductor bundled system as shown in the figure. So initially it was 2 subconductors. Now there are 4 subconductors. Initially it was R1, R1. Now it is R2, R2 and R3, R3. He's asking what is the value of radius R3. Now please understand. What is the basic idea about bundled conductors? The moment you listen this bundled conductors, what is the basic idea? A single conductor is divided into number of small radius subconductors. Why it is done? It is done to basically increase the GMR. Because if GMR is increased, the electric field stress at the surface of the conductor becomes V phase, this is GMR, ln GMD upon GMR. This is logarithmic, so GMR increasing means electric field stress reduce, so corona reduce. So bundle conductors we are using basically to reduce the corona or the electric field stress at the surface of the conductor. Now suppose here voltage is V, current is I. All these subconductors will be acting in parallel. So voltage will be same, but currents will be different. I1, I2 and so on. So if you write the Kirchhoff's current law, conservation of charge, I is equal to I1 plus I2 up to IN. You know that current is nothing but the current density multiplied by cross-sectional area, and for the transmission line, current density is constant. Why current density is constant for the transmission line? Because loads are not connected. Load tappings are not connected to the transmission line generally. Generally, the loads are connected in the distribution part. So current density is going to be constant for the transmission line. So you can understand, basically you have to equate the area. Yes or no? Both the cases, basically you have to equate the area. And if you are little more smart, then you can say, rather than writing the area, why not we equate the square of the radius? Yes or no? Because what is area? Area is pi r square. Pi is again common for all the terms. So for bundled conductors, if two such cases are given, you simply compare the area in terms of radius square. So if this is R1, this is R1, you can write R1 square plus R1 square. Other side it is R2 square plus R2 square plus R3 square plus R3 square. It becomes R1 square is equal to R2 square plus R3 square, or R3 becomes under root R1 minus R1 square minus R2 square. What is R1? R1 is given as 2 centimeters, so it becomes 4. What is R2? R2 is 1 centimeter, so becomes 1. It is under root 3 or 1.732. What is the answer? 1.732. Is it clear, everybody? Are you able to follow this? Everyone just quickly tell me in the comment section, okay? Don't be lethargic. Don't be lazy while putting the comment. Next question, he is asking the charging current. He is asking the charging current. How you are finding the charging current? Let me first give you the idea. Suppose this is a transmission line. So how you are writing the sending end voltage and current in terms of ABCD parameters as AVR plus BIR, CVR plus DIR. If you see, suppose a simple configuration I am taking for the transmission line. Suppose our transmission line is like this. Basically, it is a receiving end capacitor model for a medium transmission line, if you remember. Yes or no? this is going to be sending end voltage. This is the sending end current. This is the series impedance. This is the shunt admittance. This is the receiving end voltage, receiving end current. This is the IC current, charging current. Yes, Ashok, you're right. Now, this charging current is the current which is sent from the sending end but does not reach to the receiving end. How to calculate it? So, what we are doing, we are putting IR is equal to 0. If you put IR 0, whatever current is present in the line is nothing but the charging current. The same logic we are applying here. We are saying, let us, it is no load condition. So, IR becomes 0. When IR becomes 0, this sending end current becomes equal to the charging current. The same logic we are using here. So, what is going to be your charging current? What is C? We are only concerned with the magnitude. So, it is 0.5 10 to the power minus 4. Now, per phase voltage you have to write, because always remember, when you are dealing with ABCD parameters, you always deal in terms of per phase analysis. Okay. And charging current you will always find per phase, that it is given or not. So, voltage is 220 kilovolt. Just change it to the per phase value divided by root 3. Somewhere around 6.3 amperes you will be getting as your charging current. Again, it is a short transmission line. He is asking it is MSQ type question. It is a MSQ type question. He is talking about the sending end voltage and the voltage regulation. Now, first understand how you find the voltage regulation. For a short transmission line, your short transmission line is like this. Shunt capacitance of the charging current is neglected. This is Vs, this is Is, this is Vr, this is IR, this is the series impedance Z. Okay. Now, the general expression for writing the voltage regulation is mod Vs upon mod A minus mod Vr upon mod Vr. This is the general expression for finding the voltage regulation. So, if you see the transmission, a short transmission line, what is going to be the ABCD parameters? What is going to be the ABCD parameters? It is going to be 1, Z, 0, 1. It is simply a series impedance. So, A value is going to become as 1. So, voltage regulation will simply be mod Vs minus mod Vr upon mod Vr. Now, there are two ways in which you can find the sending end voltage and then the voltage regulation. One is, you simply write Vs is equal to AVR plus BIR. A is 1, VR you know, B is Z, IR you can calculate. IR you can calculate from here. 5 megawatt at a power factor 0.7 lagging. Okay. And the voltage is given as 10 kilovolt. So, can you find the receiving end current? Yes. Because it is single phase, so it is 5 megawatt. The voltage is 10 kilovolt and power factor is 0.7. Just solve this, you will be getting the receiving end current. Put it here, you can get it. Is it clear, everybody? Say yes or no. If you find IR, put it here, Z is given, VR is given, and you can easily find the voltage regulation. As far as I can remember, you must be getting, I think, A and B as the correct answer. Anybody is getting, just do the calculation fast. If any of you is comfortable in Hindi, you can ask me. Language should not be a barrier. Yes, it should be somewhere around 714. आप कहेंगे तो मैं हिंदी में भी बोलूँगा, इंग्लिश में भी बोलूँगा, यही 2 लैंग्वेज मुझे आती हैं, तो इसके अलावा तो नहीं बोल पाऊँगा, बट हिंदी और इंग्लिश में बोल दूँगा. So if you have any problem dealing with English, just give me a moment, okay? Sorry for the disturbance, friends, no problem. So you got the IR somewhere around 714 point. How much you are getting, Mr. Raghu? 2.28. 0.28. Just put this value. I think you must be getting the sending end voltage as 12.173, and obviously if 10 kilovolt is the receiving end voltage, then the voltage regulation you will be getting is 21.73. Is it clear, everybody? See the next question. For a given network, choose the correct statement. It is about the real and reactive power flow. So before I proceed, let me give you the idea. What is the rule? For real power flow, first you check the X by R condition. If X by R line is greater than X by R of the load, then you say that real power will always flow from leading voltage terminal to the lagging voltage terminal, or you say higher voltage phase angle to lower voltage phase angle. So, leading voltage terminal to lagging voltage terminal. Here leading and lagging simply means from the higher voltage phase angle to the lower voltage phase angle. Yes, Raghu, please wait. Simple words. जब भी X by R लाइन X by R लोड से बड़ा होगा तो ज्यादा वाले फेज एंगल से कम वाले फेज एंगल की तरफ रियल पावर फ्लो होगी, और 100% कॉन्फिडेंस के साथ आप ये कह सकते हैं. If the X by R line is less than X by R load, generally this is the case, but sometimes for distribution this may also happen. Then real power will be flowing from lagging voltage terminal to leading voltage terminal. This is for the real power. So if you check, this is one angle 30, this is one angle 0. This is leading, this is lagging. This is Jx, R is 0. Whenever it is a lossless case, R is 0, it means X by R is very high. So in general, most of the time you will be following the first case. So from higher voltage phase angle to lower voltage phase angle, so you can be 100% sure that real power will be flowing from bus number 1 to bus number 2. So statement 1 is correct, statement 4 is wrong. Let us talk about the reactive power. Now please understand, let me draw the system again. Suppose this is bus number 1, this is bus number 2, this is one angle 30 degree and this is one angle 0 degree. For reactive power, we cannot be 100% sure. So what we do, we check the flow of reactive power from both the ends. How? Let us see. First, I am assuming case 1. I am assuming that reactive power is flowing from bus number 1 to bus number 2. This is my assumption. If this is true, then listen very carefully. Mod V1 cos del should be greater than mod V2. You understand what is V1, V2? Is the magnitude. What is del? Angle. Yes or no? So what is V1? It is 1. It is 1. What is cos del? Cos 30. It is cos 30. Should be greater than 1. It is not possible. Sinusoidal function cannot have a value more than 1. It is the maximum value is 1. So this is wrong. So this is wrong. My assumption is wrong. If my assumption is wrong, it means the reactive power must be flowing from 2 to 1 as per the case 1. Now see case number 2. Case number 2, I am saying that now I am checking from the other side that reactive power is flowing from bus number 2 to bus number 1. If this is the case, then mod V2 cos minus del should be greater than mod V1, because you have to see the relative phase angle. When you are standing here, what you are searching? Magnitude here, relative phase angle here to here. So 30 minus 0 is 30. When you are standing here, magnitude V2, angle, relative phase angle 0 minus 30, that is why coming minus del. So if you write it, it comes out to be 1 cos of minus 30 greater than 1. Again not possible, cos minus theta is cos theta. So this statement is also wrong, this assumption is also wrong. Now you are getting that reactive power is flowing from 1 to 2. Now you understand. When you are assuming that reactive power is flowing from 1 to 2, it is saying no, it is flowing from 2 to 1. When you assume it is flowing from 2 to 1, the conclusion is it is flowing from 1 to 2. So what's happening here? What's happening here is basically reactive power is flowing from 1 to 2 also and 2 to 1 also. And whatever reactive power is coming here, that is being absorbed by the transmission line. That is being absorbed by the transmission line. So both the statements are going to be correct here, that reactive power flows from 1 to 2 and reactive power flows from 2 to 1. So what is the correct option? A. Is it clear, everybody? Just tell me yes or no in the comment section. Are you able to follow this? Okay. See the next question. A short transmission line has series impedance 0.08 plus j 0.12 per unit. Which of the following voltage regulation value is possible to get at the leading power factor at full load condition? I hope you know the logic here. If you draw the characteristic, this is the power factor angle and load power factor angle, and this is the voltage regulation. If you are using the lagging voltage regulation equation, that is R per unit cos phi plus X per unit sin phi. Now you see, when phi is 0, cos 0 is 1, sin 0 is 0. So what is voltage regulation? R per unit. This is coming as R per unit. Now suppose phi is 90. Phi is 90 here. When phi is 90, cos 90 is 0, sin 90 is 1. So voltage regulation is X per unit. X is coming somewhere here. It is going to be higher than R per unit because for transmission line X by R ratio is high. So you are getting this point. This is phi 0, this is phi 90 degree. Somewhere between 0 and 90, you know, you get an angle. You get an angle where voltage regulation is maximum. That is when phi is equal to theta. When phi is equal to theta, the voltage regulation is maximum value is Z per unit. This is X per unit. Now if you want, you can draw for the positive values of phi, that is, yes. So these 3 points I am going to join something like this. Now when phi is positive, right hand side, it means it is the lagging load condition. When phi is negative, it means you are going to the leading case. Now for the leading case, this is minus phi, this is a leading case. Now here, you know that at some angle voltage regulation becomes 0. Suppose somewhere here at phi is equal to 90 minus theta, the voltage regulation is becoming 0. And somewhere at phi minus 90, suppose this is phi minus 90, the voltage regulation will become minus X per unit. You are simply getting minus X per unit because the formula you are using for the lagging load, if you use it for the leading load, you will get X per unit. But the same graph we can only plot on one equation. We cannot use two equations to plot the same graph. Now if you connect these points, it is going to be something like this. Okay? Something like this. Now you understand, for all the values, when it is a lagging load, for all the values of phi, voltage regulation is always greater than R per unit. It is above R per unit. And when phi is leading, voltage regulation is always less than R per unit. For lagging load condition, voltage regulation can only be positive. Always more than R per unit. But for leading load, it can be positive also. From here to here it is positive, here it is 0 and here it is negative. Can be positive also, can be 0 also, can be negative also. This is the complete picture. He is asking, at the leading power factor, full load condition, what is the possible voltage regulation? So you know, for leading power factor, voltage regulation must be less than R per unit. What is R per unit? 8%. So not possible, not possible, not possible. D is the correct answer. Only 4% is possible. Is it clear, everybody? Are you getting? Do not forget to comment. If you don't comment, then I'm going to know whether you are able to follow me or not. So let us see this question, very beautiful question for the synchronous phase modifier, phase advancer. A three-phase induction motor of 500 horsepower, 90% efficiency at 0.8 power factor lagging. The moment you get this statement, your mind should understand that the question wants to give you the real and reactive power taken by the motor from the supply. Why he is giving you efficiency? Output is given 500 horsepower. Efficiency given, you can find the P input. Power factor given, you can find the Q input. Yes or no? So this three-phase induction motor, suppose it is going to have P induction motor plus J Q induction motor. This is the real and reactive power taken by this induction motor from the supply. Now he is saying there is a loaded 120 kilowatt synchronous motor connected so that the overall power factor becomes unity. What is the meaning of this overall power factor becomes unity? Please try to understand. When you say power factor becomes unity, it means phi becomes 0. Phi becomes 0 means what? If this is P, this is Q, this is S, this is phi. Phi can become 0 if you make q is equal to 0? Yes or no? If you make q is equal to 0, then only phi is going to become 0 and cos phi become 1. Now, what is this P and what is this Q? When you are saying the overall power factor becomes unity, then it is not about the load only. You can never change the load power factor. Once you design the load, the power factor of the load is fixed. The only thing you can do is you can improve the overall power factor of the system. So it means you are talking about this P and Q. You are saying this Q is 0. That is, the reactive power coming from the supply side is 0. So it means whatever reactive power is supplied by this synchronous phase modifier is going to the induction motor. So can I write Q synchronous motor is equal to Q induction motor? Yes. You know what is P synchronous motor. You can find what is Q synchronous motor. He is asking what is the power factor of synchronous motor. Can you calculate? Yes. First, for the 3-phase induction motor I am writing, efficiency is given as P output upon P input, or P input is going to be P induction motor. P output is 500/746 divided by efficiency is okay. So efficiency is 90%. Efficiency is 90%. Okay. Just solve this. What is P induction motor you are getting? Just solve this. If you know the power factor, you can also write the reactive power taken by the induction motor from the supply, that is P induction motor tan phi is cos inverse. What is the power factor? 0.8. So it is 0.8. Both the values P and Q you can solve. Please tell me the value for P induction motor, because Q you must be getting somewhere around 310.83 volt ampere reactive. Yes or no? So friends, your favorite and my favorite Arno sir is with us. Please welcome him. Hello sir.
Okay, hello sir, hello everybody. Okay, I just come to say that guys, many students are saying that the sir exam will be tough, then what to do, exam will be easy, then what to do. Let me tell you guys that this is a competition exam, not CBSE exam, 12th class, that you have to score 90%. Okay, here the performance is relative wise, and once the performance is relative wise, the toughness or easiness of paper is not mattering much. If it is tough, it is tough for everyone. You need not to worry in the exam. If it is easy, then again you don't have to be cool, or you don't have to be extra relaxed or in overconfidence, because it is easy for everyone. And let me tell you one truth also, that how much the paper will be tough, that much the distinguish between the real aspirants who have worked hard and the other students, the difference will come much. So always try those students who are literally preparing for GATE examination, that if paper is slightly on the tougher side, then the real students who have done hard work will be having a better rank. I thought you also agree.
Yes sir, definitely sir. It is always advantageous, and I think for GATE examination, if the GATE examination question paper is little difficult side, then it will be much better, because if it is easy na, so everybody is very close. Marks are very close.
Standard deviation
ज़्यादा नहीं आएगा. तो सर अभी लास्ट मोमेंट पर जैसा कि आपने बोला कि बच्चों को ये सब टेंशन नहीं लेनी चाहिए, लेकिन मुझे ऐसा लगता है कि कहीं ना कहीं बच्चे लूज कर जाते हैं. उनको लगता है कि मतलब मुझसे नहीं हो पाएगा. तो कुछ उसके लिए एक दमदार मोटिवेशन आपकी तरफ से.
दमदार मोटिवेशन तो क्या है सर, हम तो खुद ही आपसे मोटिवेट होते हैं.
अरे सर,
आप इलेक्ट्रिकल का जितना भी पावर सिस्टम है, मशीन है, जो भी है सर से गाइडेंस ले ही रहे हैं. और मोटिवेशन सिर्फ इतना ही है कि देखो, आदमी टेंशन क्यों लेता है या नर्वस क्यों होता है, कि उसको लगता है कि एग्जाम क्लियर नहीं हुआ तो कुछ नहीं होगा. देखो, एग्जाम क्लियर हो गया तो अच्छी बात है. अदरवाइज लेट मी टेल यू, देयर इज नॉट अ सिंगल स्टूडेंट इन दिस कंट्री हु इज ओनली प्रिपेयरिंग फॉर गेट. यू विल बी गिविंग बार्क आल्सो, यू विल बी गिविंग स्टेट सर्विस एग्जामिनेशन आल्सो, यू विल बी गिविंग द PSUs which take their own exam also. So your career is not depending on a single exam. There are multiple exams, And for that, what to do? Suppose the cutoff is here, and you are thinking that you are here right now. So you are thinking that you will not be able to clear the cutoff. That's why you are not preparing much now, and you will be here only then. Then again, the exam will be in March, April of BARC or other examination. Then you will start from here. So it's better to start preparing. You will reach near to cutoff. If you clear the cutoff in February in GATE, it's well and good. Otherwise, you will be very near to the cutoff, near to the threshold level, and then the coming exams that will be in April, May, June. So you just have to move a little bit to cross that threshold level.
Definitely, sir. So one more point I want to add here. All the candidates, sir, I think who are appearing for the first time in the GATE examination, for those candidates, sir, I think they should be giving their 100%. बिकॉज एक बार आपने बच्चों अपने पहले अटेम्प्ट में, जो आपका पहला अटेम्प्ट होता है ना, वो सबसे प्रीशियस होता है.
बिल्कुल सर.
उसमें अगर आपको एक सही डायरेक्शन मिल गई तो उसके बाद आपको सिर्फ एड ऑन करना है, आपको अपने रेंज को बढ़ाना है. बट अगर पहला ही अटेम्प्ट गलत डायरेक्शन में था, आपने पूरी तैयारी नहीं करी, अपना 100% नहीं दिया, तो कहीं ना कहीं वो आगे के अटेम्प्ट्स को भी अफेक्ट करेगा. तो जो अगर पहला अटेम्प्ट है आपका, तो पूरा जी जान से दो, और उसके बाद आपको सिर्फ रिवीजन ही करना है. बिल्कुल. चीजों को ऐड ही करना है. ठीक है सर.
अगर आप 2 मिनट दें अलाउ.
हाँ सर, बिल्कुल.
एक चीज बस बच्चों को बताना चाहूंगा. दोस्तों, स्टूडेंट्स, यू आर थिंकिंग ना, व्हाट इज, सर प्लीज आप भी, स्टूडेंट्स, यू आर, मेनी स्टूडेंट्स आर आस्किंग व्हाट इज द डिफरेंस बिटवीन गेट एंड अदर एग्जामिनेशन. लेट मी टेल यू, गेट and other examinations like ESC, like state service examination, state PCS, or it can be PCS, or it can be JE, or the PSUs which take their own examination. What is the difference? Let me just tell you very clearly that in any competition exam, there are 3 types of questions. In any competition exam, and if it is any GATE, ESC, any, one is conceptual, where only knowing the formula will not help. Along with formula, you have to know, you should be knowing the concepts, how to apply that formula, and related things, assumptions, and validity of the formula. Everything has to be required here. The second type is only formula based. V is equal to IR or whatever. V and I is given, R is required. Okay. And third one is data based. Okay. Data based. What is the data of that? What is the temperature there? What is this? That is data based. So GATE will be asking questions now. 60 to 80% questions will be conceptual, 15 to 20% maybe of 1 marks will maybe of formula based, and rarely 0 to 2% questions will be data based. But when you come to other examination, the conceptual formula database are almost 33 and 33%. Might be these two a little bit more, and this can be 25-35. But here, other examination ESC states that, because there here you will be getting 3 minutes for one question. 65 question, 180 minutes. Here is ratio is 1:1. One question, 1 minute. So all questions will be here equally divided. So GATE requires the vertical depth of the syllabus. Okay. But only the conceptual things will be asked, but at most depth. But ESC is the horizontal. Vast coverage is required. I hope, sir, you agree.
Yes, sir, definitely. I think very great input sir has given to all of you. So please take that input, and thank you so much, sir, for coming to this.
10.83.
Sir.
Okay, sir. 10 cos inverse. Too much calculation in your branch, sir.
No, sir, no, sir. It's very easy actually, because we almost so much practice students are doing that they actually remember the data.
I also know, sir, a little bit. The force between two charges k q1 q2 by r square. K is 1 by 4 pi epsilon 1.
That is the basics.
Electric field is the force on, electric field is a vector, force on 1 plus 1 unit charge. Potential
Yes,
is scalar, work done from infinity to r distance.
We also know about friction.
Okay, sir.
Okay.
Thank you guys. Carry on, all the best.
Thank you so much, sir. Thank you. I will catch you up, sir, later.
Okay.
So guys, that was the great legendary faculty from civil engineering. I hope you must be quite excited about the inputs given by sir, and he is always there for you. And I always take guidance from sir whenever I am in difficult times, whenever I am little depressed that sir, I am stuck there, what to do next. So he used to guide me, even though he is less in age in comparison to me. Anyways, so with this question, we were saying that you got the reactive power required by the induction motor from the supply, and from the supply side, if the reactive power coming is 0, so whatever reactive power is supplied by the synchronous motor or the synchronous phase modifier is going to the induction motor. So Q synchronous motor is also going to be 310.83 volt ampere reactive. What is the real power taken by the synchronous motor? That is 120 kilowatts. So very easily you can write, for the synchronous motor, what is the power factor? This is phi synchronous motor, this is P synchronous motor, this is Q synchronous motor, and this is under root P square plus Q square. So what is going to be the power factor of the synchronous motor? I think it is going to be PSM upon under root PSM square plus QSM square. But there is one more twist in the question. There is one more twist in the question, because I think you must be getting somewhere around 0.36. The magnitude you will be getting is 0.36, but at the same time you have to identify whether it is a leading case or it is a lagging case. Now I am going to give you a very smart technique how to identify whether it is a synchronous generator or synchronous motor when you are going to have the leading power factor, lagging power factor, or a unity power factor. What is the basic nature of motor? The basic nature of motor is to absorb power, yes or no? So if it is the overexcited condition, it is E cos del greater than mod V. So your synchronous motor behave as a source of lagging reactive power, Now you tell me, the basic nature of motor is to absorb power, but here it is supplying the lagging reactive power. If something is supplying lagging reactive power, it means it is absorbing the leading reactive power. So what is the operating power factor? The operating power factor becomes leading. I hope you are getting my point. Second is underexcited condition. For the underexcited condition, mod E cos del is less than mod V. Now your synchronous motor act as a sink of lagging reactive power. So what is the operating power factor? Now operating power factor is going to be lagging. Third condition, when it is normal or level excited. In this case, mod E cos del is equal to mod V. It is neither a source nor a sink of reactive power, so the operating power factor becomes unity. It is a unity power factor. So if you see in this case, your synchronous motor is supplying lagging reactive power. What is the basic nature of synchronous motor? To absorb. It means if it is supplying lagging reactive power, it means it is absorbing leading reactive power. So what is the operating power factor? It is leading. So B is the correct option. Everybody is getting this technique? Yes, lifestyle, are you getting this? It's not lagging, it's leading. Hello. बात समझ में आ गई? Getting the point? Go to the next question. A three-phase transmission line has a series impedance of 5 plus j20 ohms per phase and delivers a load of 30 megawatt at 0.8 power factor lagging at 33 kilovolts. Find the reactive power supplied by the synchronous condenser. First, you understand what is the difference between a synchronous condenser and synchronous phase modifier. Synchronous phase modifier and synchronous condenser. What is the difference? In one line I will give you the difference, and more than that is not required. It is overexcited synchronous motor having some real load on shaft. What does it mean? It means it absorbs real power from the supply and it supply lagging reactive power to the system. What about the synchronous condenser? This is also overexcited synchronous motor, but it is at no load. When it is at no load, So P exchange is 0. There is no exchange of real power for the synchronous condenser. And Q is supplied. Q is supplied. Okay. This is the basic difference between synchronous condenser and synchronous phase modifier. That is why there is no real power exchange. So it is supplying some lagging reactive power to the system. This is the real and reactive power requirement of the load, and this is the real and reactive power coming from the source side at the receiving end. The receiving end and sending end voltages are same, 33 kilovolt. Now you cannot apply the shortcut formulas in this question because it is not lossless. Resistance is also there, 5 plus J20, you have to use Z. Here you have to follow the detailed formula. Can you tell me what is the expression for P and Q? Can you tell me what is the expression for P and Q? Yes? Remember, PR is mod Vs, mod Vr, mod B cos beta minus del minus mod A, mod B, mod Vr square cos beta minus alpha. What is the reactive power received? Mod Vs, mod Vr, mod B, sine of beta minus del minus mod A, mod B, Vr square, sine of beta minus alpha. Now I am writing these two equations because in the question, he is giving you the real power delivered to the load. The real power delivered to the load is given as 30 megawatt. I want to find the Q value. I need to find the Q value. Do you know Vs? Yes, 33 kilovolt. 33 kilovolt. What is B value? This is nothing but magnitude Z. Z is given. Z is mentioned. 5 plus J20. 5 plus J20. This is Z. You can find the magnitude also. 5 square plus 20 square. You can find the angle also. Tan inverse 20 upon 5. So you know what is the Z value. What is beta? Beta is the angle of Z. This is nothing but tan inverse 20 upon 5. Del you don't know. A is 1. B is again tan inverse 20 upon 5. Vr is 33 kilovolt. Beta is again tan inverse 20 upon 5. Alpha is 0. So you know all the values for calculating Q except the del value. And this del value you will be getting from this equation because you know this is 30 megawatt. Rest values you know. You don't know what is del value. So from the P equation you will find the del value and put this value del in the second equation, then you will be getting Q. But this is not the answer. What he is asking? He is asking find the reactive power supplied by the synchronous condenser. So whatever power is coming from here, reactive power, whatever coming from here, both going to the load. So QR plus Q synchronous condenser is QC is equal to Q load. Yes or no? What is Q load? Real power given, power factor given. So you can write it is P load tan of cos inverse 0.8. So if you calculate QR, you have the P load. Can you calculate QC? Yes. You must be getting C as the correct answer. Do the calculation as part of your homework. Do the calculation as part of your homework. Is it clear, everybody? See the next question. 4 identical insulator discs are connected in the form of a suspension type string insulator. The ratio of shunt and mutual capacitance is given as K, that is C dash upon C 0.2. If the total string voltage is 40 kilovolt, then the string efficiency will be if a static shielding, that is the guard ring, is connected with the bottom 2 units. So it's something like this. Suppose this is your suspension type string insulator. This is your conductor, live conductor. Okay. Now, this is C dash, this is C. Ratio of C dash and C is K, this is given. Let us write the currents. Current here is I4, here it is, here it is I3, here it is I2, here it is I1. This is I1 dash, this is I2 dash, this is I3 dash. What the static shielding is going to do, let us understand. What the static shielding is going to do, this is suppose the static wire or guard wire. They are going to compensate for the I2 dash and I3 dash because only bottom two units are compensated. So this guard wire is going to supply I3 dash from here. Similarly, I2 dash from here. Now you can imagine, just imagine here. It's very interesting. You just imagine, if I3 dash compensated, then I3 is equal to I4. When I2 dash compensated, then I2 is equal to I3. So can I write I2 is equal to I3 is equal to I4? Yes or no? This is the meaning of compensation by guard ring or static shielding. If the currents are same, if the capacitances are same, then can I say the voltage across second unit, third unit and fourth unit are going to be same? So can I say V2 is equal to V3 is equal to V4? Yes. What is V2? V2 is V1 1 plus K. What is K? 0.2. So it is 1.2 V1. He is asking what is the string efficiency. How you are writing the string efficiency? The string efficiency you are writing as V1 plus V2 plus V3 plus V4 divided by number of units and the voltage across the unit nearest to the conductor, that is V4 multiplied by 100%. V1 is V1. Now V2, V3, V4 are same. So 3 times. Now what is V2? 1.2 V1 divided by N is 4. What is V4? It is nothing but V2. So 1.2 V1 multiplied by 100. Just solve it. You will be getting your answer. Is it clear, everybody? Are you able to follow this? Tell me. Tell me in the comment section, are you able to follow this or not? Is it clear, everybody? See the next question. A radial distribution system is fed from both the ends. Each conductor is designed to have a resistance of 0.15 ohms for 300 meters. The current current tipping. I don't know what is this current tipping. Okay. Okay, maybe this tipping he is writing in terms of load connected. Okay. Let me redraw this circuit. There is little confusion in this circuit. It is something like this. It is a radial distribution system fed from both the ends. This is V1, this is V2. This is V1, this is V2. Now there are 3 loads connected, 20, 60, 40. 20, 60, 40. Okay. Now, the length of the distributor section is 50, 100, 50, 100. So, this is, we are assuming R1, this is R2, this is R3, this is R4. R1 and R3, they belong to 50 meter, and R2 and R4, they belong to 100 meter. That's it. Now, what he is asking in the question, actually something is missing. Basically, you have to find, I am writing here, find the value of minimum voltage on the distributor. Find the value of minimum voltage on the distributor. How to find it? When you have a radial distribution system which is fed from both the ends, what is going to be the location of minimum voltage? The location of minimum voltage will be the point where you are getting current from both the sides. But before solving it, we don't know what is the direction of current. So you can assume any current direction of your choice. Suppose you are assuming this is I. So here it is going to be I minus 20. Then 60, so it is I minus 80, and this is I minus 120. We are assuming randomly. After analyzing the circuit, if any section is getting a negative value of current, then simply you have to, same magnitude you have to take, but you have to reverse the direction of the current. That's it. This is what you have to do. Now, we have assumed this direction. First, we have to find the R1, R2, R3, R4. Whenever you are dealing with the questions related to the distribution system, always remember you should deal in the loop resistance. You should deal with the loop resistance. If it is mentioned in the question, then it is okay. It is not mentioned. He is simply giving you the resistance. So you have to find the loop resistance. What is going to be loop resistance? Loop resistance is 2 times the resistance, that is 0.15 ohms for 300 meters. Can you tell me what is going to be R1 and R3? It is 0.3 per 300 meters. So 0.3 divided by 300 into 50. What is R2 and R4? It is going to be 0.3 divided by 300 multiplied by 100. This I think you must be getting somewhere around 0.05 ohms. This you will be getting as 0.1 ohms. Now write the KVL. How you are writing the KVL? V1, V2 is same. V1, V2 same means, let us first write the KVL equation. If you write the KVL equation, it is going to be V1 minus I R1 minus I minus 20 R2 minus I minus 80 R3 minus I minus 120, and this is R4 equal to V2. This is how we write the KVL equation. But V1, V2 is same. So V1, V2 cancelled. And we know one thing, that R2, R4 are 2 times of R1 and R1 or R3. Are you getting that? So in place of R2, R4, we'll write 2, R1, R3, 1. Now you can simplify, and this minus I am making as plus. Multiply by minus. So finally you will be getting I plus. It is 2I minus 4. 2I minus 40 plus I minus 80. I minus 80. This is 2I minus 240 plus 2I minus 240 is equal to 0. This is 1, 3, 4, 6. So 6I. This is 8, 4, 120, 240, 360. Then I comes out to be 60 ampere. Just put the value of I and check whether you have assumed the right direction or not. If this is 60 ampere, I is 60 ampere, here it is 60 ampere. 60 minus 20 is 40 ampere. 60 minus 80 is minus 20. The moment you get minus current, keep the magnitude and reverse the direction. So it becomes 60 minus 80 is minus 20. So this is 20 in this direction. 60 minus 120 is minus 60. So this is 60 in this direction. So this is going to be the location of minimum voltage. Now very easily you can find, you know the resistance, you know the current in each branch. Very easily you can find V minimum. What is going to be V minimum here? It is going to be V1 minus I into R1 minus I minus 20. Or simply write the current values. Now you got the current values. So why to write? Make it complex. Or put the value of V1 also. What is V1? It is 230 volts. So V minimum is going to be 230 minus I is 60 into R1 0.05 minus it is 40. R2 is 0.1. Just solve it, you will be getting your answer. Is it clear, everybody? So I think you must be getting it 7. Total it is 7. So it is 223 volts. See the next question. There is a 250 meter distributor fed from both the ends, has a uniform current loading of 2 ampere per meter. Find the location of minimum voltage and its value. Now understand, there is a formula for the location of minimum voltage which is at a distance x. Suppose it is at a distance x from one end. So it is V1 minus V2 upon LIR plus L by 2. Just put the values. 225, 220, it is 5. What is the length of the distributor? 250. What is the current loading? 2 ampere per meter. What is the resistance per unit length? So no need to worry because loop resistance is directly mentioned. So it is 0.2, but it is per kilometer. So divide by 1000 because we have to write per meter. Plus L by 2. So it is 125. To solve this, I think you must be getting 175 meters. The moment you get the X value, what is going to be the value of this minimum voltage? This voltage minus voltage drop in the X distance, yes or no? Sorry. So V minimum will be V1 minus voltage drop for X distance. It is going to be V1 minus, listen very carefully, how you write the voltage drop? IR X square by 2. What is V1? 225. What is I? 2. Okay. What is R? Again 2 divided by kilometer. What is X? 175 square divided by 2. Just solve this. This is your minimum voltage. Is it clear, everybody? So some questions I'm giving you as part of your homework. Just do these questions. I think you can do it. 2-3 questions are there. Underground cable. Okay. Easy questions. You can do it. So this is all from my side for today's session. In the next session, I will be talking about fault analysis, circuit breaker, relays, economic load dispatch. So this is all from my side. Thank you so much for joining me live in the discussion. Stay connected. Do not forget to like, share and subscribe the session. And the next session, be aware, be alert so that you do not miss that session. That is going to be important session. I will be covering fault, protection, circuit breaker, relays, economic load dispatch, all the important topics. Thank you so much. Take care. Thank you.